Okay, so last we left off, we wanted to talk about the combustion reaction. So primarily we're talking about the combustion or oxidation of organic material or burning or, let's see, combustion, burning. What is the other term? Cole, help me out here.
Combustion, burning, oxidation. There's another term.
There's one more. It'll come to me later. It always does. Okay. I'll be on the toilet or something, and then I'm like, oh, that's what it was, you know. Okay, too much information, I know. So when we talk about combustion, oxidation of organic material, and burning of things, typically we're talking about organic material. So that whole concept of learning organic chemistry was going to come in handy. Help me out here. What is this guy? What is this chemical right here? What would be the name of this compound? Come on, you guys, just take this test. Somebody should be raised up to tell me what it is. Okay, fine. I'll pick on you. Eileen. Start with the A's and work our way down.
Can I answer?
Yes, you can.
It's propane.
Yeah, so this is propane. Propane has how many carbons?
3.
So propane has 3 carbons. So 1, 2, 3. Okay, so we know that it's going to be C3. Now, how do I calculate the number of H's? Well, it's propane, A-N-E, which means it's saturated. It's going to be saturated with H's. What do we know about carbon? How many attachments can carbon have?
4.
At least 4.
At least 4. It could have at least 4. Since it's saturated, it means that it's going to use all of its attachments. And all of those other attachments, other than the ones that are attached to carbon, are going to be attached to hydrogen. So we'll have a hydrogen here, and a hydrogen here. So that would give it, this carbon, its 4 attachments. How many attachments are left to have hydrogens for the carbon in the middle?
Would it be 2?
That is correct. It would be 2. Go ahead, Asena. Okay, and what about this last carbon?
3.
3. Okay, so I'm going to say something that's totally sexist, and it's meant to be totally sexist. So I don't understand why there are not more women scientists in the academic community. Because if I look at my class, look how many of you guys are women.
It's basically all of us.
Yeah, I think I have no men that show up to class, right? It's all women, right? And who are the ones that typically are participating, that are interacting? How often do you hear a deep voice? This, Dr. Henry. How often do you hear that?
Rarely.
Rarely. And if you do, it's usually a woman who has a cold or who has a sore throat or something like that, right?
Yes.
So I guess I don't get it, right? I don't understand. You guys are primed to be dominating this field. You guys are smart enough, clearly, right? But a lot of you guys, I don't understand. Majority of you guys are nurturers, I guess. And you decide, oh, I'm going to be a nurse, or science is just not for me, right? I don't understand. You guys you're acing the test. You're answering the questions. You're dominating the area. It's your wheelhouse. Science is your wheelhouse, but those are choices our one male comes into class as soon as I say this, right? But those are choices that we make. We're like, oh, I'm just going to go into nursing. Or rather than, I'm going to be the doctor. Or I'm going to be the chemist. Or, I'm going to be the PI of that lab. You choose to take a back seat. I don't understand why, because you should be taking front seats. You should be in the driving chair. You know what I'm saying? And I know it's sexist, but I don't care, right? I'm just telling you the truth. You can send a report on me later on. You guys are capable of more. A lot of you guys are capable of more, and you sell yourself short. I think you guys are brilliant. Okay, anyway, that aside, how many hydrogens do I have?
8.
So H8. So we are able to sit there and use what we know and what we've learned about nomenclature and all those things to sit there and get our chemical formula, just in case it's not given to us, right? Brilliant. Look at that. Okay, so combustion always requires oxygen. You need oxygen to burn. So we're always going to have oxygen gas. And as a result, if we have no other things that are in there, we're going to have a clean burn, right? Clean burn is going to give us carbon dioxide, gas, and H2O. Now, is this H2O going to be a gas or is it going to be a liquid? Now, think about it. Be practical. Think about fire. Is it going to be a gas or is it going to be a liquid?
Yes.
Gas.
It's going to be a gas, right? Because it's fire. Okay. Okay, so now this is the equation. Can we balance it?
Yes.
How?
The carbons are uneven.
Okay, so we're going to use our CHO, C, H, and O. So how many carbons do I have on my reactant side?
3.
3. How many do I have on my product side?
1.
1. Okay, so now this is the funny thing, right? So I just gave all of the women that are in the class, we have one guy that comes in. Then all of a sudden that one guy comes in and all of the women stop talking. What happened?
I was just giving someone else a turn.
You're just giving someone else a turn? No, take your turn. Hey, you own this. Own it. Occasionally I'll tell you, but I think you're talking too much. I'll let you know. Usually I have to tell Diego, give somebody else a turn, right? Haven't I done that, Diego?
Yes.
And I've done it to you too, Whitney, occasionally. So if nobody else is talking. Okay, Whitney, help me out here. How many hydrogens do I have on the product side?
On the product side?
On the product side.
2.
And on the reactant side?
8.
Erica, are you at work? I see you twice. Or is that-
No, I don't know what's going on.
that
No, I
two
think
different-
it's 2 different ones.
2 different Ericas?
Yeah,
I
I
know
don't
I
have my
had
last
2.
name on it.
Okay, so I have to be honest with you guys, right? So I was like, I think I have 2 Ericas. And then I'm like, no, I have 1 Erica. And then I'm like, no, I have 2 Ericas. And then I'm like, no, I have 1 Erica. And I've been writing to both of you guys for different things. I'm like, I thought I talked about this already with her. Didn't I send this email? And it took me a while before I realized it was 2 different Ericas. I'm special sometimes. Okay, Erica A. And then we'll go with Erica M, if I remember correctly, right?
Yeah, that's my last name.
Okay, Erica A, tell me about the oxygen.
You have 2 on your reactant side, and then 2 on your product side too.
Is it 2 or 3? Did you say 3?
No, I said 2.
Okay.
That's a 2, right? Yeah.
There's 2 here, but what about this one? You got to add that one.
Oh,
to it.
3. Yeah, 3.
Yep. Okay, so now we know how to do that, right? Now, what do I need to do to sit there and balance the equation? Erica M. So I have 3 carbons on my reactant side, and I have 1 carbon on my product side. What am I going to do to make it so that that product side has 3 carbons to balance it out?
We can add a 2 on carbon.
Am I going to add a 2? Now think about it, because it's all multiplication at this point, right? Because our chemical compounds are set the way they are. We can't change those.
Yeah.
So now we're going to be multiplying.
Yeah.
So what if I'm going to do?
Mm-hmm.
Multiply it
Multiply by what?
3.
By 3. So I'm going to put a 3 in front of the carbon dioxide. Is that what you're telling me?
Yeah.
Yeah.
Okay. By me putting a 3 in front of that carbon dioxide, that's 3 times, and this is understood to be 1. That gives me my
3.
3. Yeah. Then let's count those oxygens, because we kind of have to keep a running total, right?
Yeah.
So how many oxygens do I have now?
6.
6 here, plus.
Oh, 7.
7.
Okay. So, Erica, let's see, which Erica was that? Did I get both Ericas? See, now,
Yeah,
see, I
you
told you, I
did.
forget things.
You did.
Ariana.
Yes.
Oh, she sounds so sweet. Okay, Ariana. That's the way she sounds in class. You should hear her in the schoolyard or in the, walking the halls. She's not so sweet. She's just playing with us.
No,
Here I
I'm
am.
just loud.
You're just loud?
Yeah,
Just
if I
a little-
walk in the halls or something, I'm always loud. I'm never
Okay.
quiet.
So you try to be sweet in class, huh? Okay, I get it. I understand. Okay, Ariana, tell me about hydrogen. So we have 8 on one side and 2 on the other. Is that balanced?
No.
No. So what do I need to do to balance it out?
We have to.
Think about what we did with the other one. Remember, at this point, our equations are set. So now all we're doing is multiplying. Our formulas are set. All we're doing is multiplying. So what do I need to do? I have 2 on one side. What's going to give me 8? What do I need to multiply by?
4
4. So where am I going to put that 4?
in front of the 8.
Okay, in front of which? This H over here?
Yeah.
Or H2O? Okay.
Yeah.
Okay, so then that gives me a total of 4 times 2.
8.
8.
Okay, that gives me 8, right? And then let's count those oxygens now. So we have 3 times 2. Sorry, brain is working faster than my mouth.
6.
6. And 4 times 1.
4. Yeah.
4.
We add them together.
It's 10.
10.
So we have a total of 10 oxygens. Do we have 10 oxygens over here?
No.
So what do we need to do to make it so it's 10 oxygens?
Put a 5 in your
Apply
reactant
the
sign.
Oxygen molecule.
There we go. We put a 5 there. Look at that. Bam. 10. We have a balanced equation. Isn't that beautiful? Don't you feel good? I love when I get a balanced equation. I just feel so tingly all over. Okay? Pretty good so far? Do you guys get it?
Yeah.
Yeah.
Okay, excellent. Now that you get it, I'm going to throw a curveball at you like crazy. Okay, you guys ready?
No.
Nope.
Yeah, you got
Kind of.
Kind of. Okay, I like kind of. Kind is a good start. We're building up. Okay, so let's get ready. So let's change it. Let's change it up just a little bit. So instead of having propane, let's have butane. Okay, so give me the chemical formula for butane. How would I go about that? Let's go through that process again. See, and I think you guys are special. I think you guys can get it, where some of my other students, they have a hard time understanding that. So I'm going over this with you guys because I know you guys, you're there with me. I feel it. You guys try to be shy, but I feel you're there with me. So help me figure this out. Butane, but. How many carbons?
4.
4.
4 carbons. So we know that there's going to be 4 carbons. And it's an A and E. That means it's going to be saturated, which means that we're only going to have single bonds, right? So then how many hydrogens must be added to all of these to make that true?
11.
11? Are you sure?
I say 10.
10.
So we have,
Because you're going to have there 3 hydrogens and then the other carbon 2, and then the other carbon 2, and then in your last carbon 3. So in total, you have 6. I mean, you have 10.
okay,
10 hydrogens.
good job.
Oh, yeah. I added an extra one.
Okay, so okay, so now we have this. Let me erase that 5. Okay, so what is my first step to balancing my equation?
Write out the CHO.
Okay, how many carbons do I have on my reactant side?
10. Oh, 1. 1.
Reactant? Are you sure? 1?
4. Sorry,
4.
I thought that was like in parentheses or something.
Yeah, good job, Mandy. Mandy put it up there. I'm just a little slow at reading. And Eileen. Eileen tells me, okay, I have 1 on my product side. Okay, good job. Okay, so hydrogens.
10.
And on the other side?
2.
Okay, there we go. Good job, Mandy. 2 on the other side. Oxygen.
2 on one side. And then 3.
Okay. Okay, is it balanced?
Nope.
Nope. What do we need to do? What do we need to do to balance it? Again, hit faster than my mouth.
Carbon, we add a 4 on the product side.
Okay. And that gives me how many oxygens?
8.
Plus.
Oh, 9.
Okay. Hydrogen.
Do we add 5 in front of H2O on the product side?
Okay. Good job, Eileen. She's also contributing there. Yes, that's right. We have 5. That was Erica, right?
Yeah.
Okay, Erica M. You go, girl. Keep it up. So that's 10.
So it's 8 plus 5
Okay.
equals 13 oxygens.
Okay. That's a 13. Let me erase that. Okay. So we have a problem, right?
Yeah.
Yeah, so this is a problem here. Now, if you guys remember, we had talked about, oh, if you have a particulate at the particulate level, at the molar level. At the molar level, I could have a half of a thing. But at the particulate level, I can't have a half of a thing because you can't have a half a molecule, right?
That's where we do the extra step. That's gonna be 13 over 2. So you're gonna leave times the whole thing by 2, except for the reaction. You're gonna leave the 13 in the reactant sign next to the oxygen 2.
Okay, you beat me to my point. Yeah, so here we're gonna use 13 over 2. 13 over 2 is gonna cancel out. So then we
Sorry,
end
I
up with
got
just,
a little bit excited.
I'm glad, that's good. See, chemistry does that. It makes you tingly too? Good. Okay, so now we're gonna multiply this whole equation by 2. And then I need space. I'm gonna write on top.
Is it because of that extra step we're multiplying times 2 the whole equation?
That is correct, because we want things to work in both situations, at the particulate level and also at the molar level. So at that small level, right? So then that way we're getting rid of that half, or we're getting rid of that fraction, so that we won't be able to, we'll be able to use the equation under both circumstances, right?
Yep.
So if we're just working with single molecules, or if we're working with a whole bunch of them. So does that make sense?
Yeah.
Okay, so we ended up with 2C4H10 plus, what is 2 times 13 halves?
13.
And then 2 times 4,
8,
and then 2 times 5.
10. I got the same thing for my answer. It's just I use a different method. Similar to yours, but I still got the same answer.
Okay. As I told you, there's multiple ways of getting there. As long as it gets you to the correct answer, that's what I care about. And you understand what you did. You can apply it to other things. Okay? Piece of cake? Strawberry
Definitely.
cake?
Yeah.
Good. See? Everybody agrees strawberry cake is the best. Okay. How you feeling? You feeling pretty good about this? You feeling comfortable? Ready to move on? What do you mean? Are you calling me a bully? Is that what you're saying? Okay. So, let's start with this. Can you see a whiteboard now? Just a whiteboard?
Yeah.
Man, you said
Yes.
yes. Okay. Okay. So now, how many of you guys have baked a cake? Strawberry, chocolate.
I have.
I have.
Me.
Has anybody in our rooms so far not baked a cake? Okay, everybody's baked a cake. Excellent. So I'm expecting a whole bunch of cakes, right? So it kind of works both ways. If you never bake the cake, then you get to bake the cake, right? And if you bake the cake, then you get to bake the cake. So it works both ways. So let me let you know, I like strawberry cake with chocolate frosting and sliced strawberries, okay? Just so you know, just letting you know right now, okay? Okay, good. So now that you know that, and you guys all know how to bake a cake, how many of you guys bake the cake out of a box and not from scratch?
Depending.
Yeah,
Depending.
done both.
Yeah.
Could we say that everybody has baked the cake out of a box?
I have not.
No.
No, not everybody's baked a cake out of a box. Okay,
No.
Maybe.
maybe. Okay. So since there was only one person that said maybe, okay, so then we'll keep going on with this cake. I like cake, and I have a sweet tooth, and I want some cake. I'm just saying. So, and that isn't going to get you an A, Eileen. Nice try, though. I told you what get you an A. I'm like, if I'm going to give people A's, I'm going to make sure that I'm set for life. Okay, so let's talk about this cake. So if I was baking a cake, what do I need? What is the recipe for that cake? Can anybody give it to me? Or a couple of you guys give it to me? So I
It's
know
like
I
a
have that
box.
the box.
Yeah, you've got the box, and then you've got like usually it's like a 1/4 cup of oil and 2 eggs, and then
Okay.
maybe a cup of water.
Okay, so just so you know, we're gonna get rid of that oil. We're gonna put butter because butter makes everything better. Okay.
Okay.
So how much butter would be a cup of oil, or
Uh,
quarter of a cup of
a
oil?
1/4 cup is half a stick.
Okay, so we'll go half a stick of butter. Okay, and you said I got the box, I got the stick of butter. You were talking real fast. I'm a
Yeah,
little
like
slow today.
2 eggs, and then usually it's like half a cup or a cup of water.
So can I put milk in it instead? Because milk makes everything taste better.
Sure.
Okay, I'm just making modifications. That's all. Okay, because we want it, we want it to Dr. Henry's taste here,
You're just letting us know how to bake your cake, huh?
I'm just being subtle. That's all. Just a little, just little hints. Mandy, healthy. Come on, it's cake. It's not supposed to be healthy. Oh, it tastes good too. Maybe I'll try that applesauce. Huh? I have to give that some thought. Okay, so this is the recipe for the cake, right? So this is going to add all of these together. This is going to give me 1 cake. Is that true?
Sure. Yeah.
Okay.
Yes.
There's nothing I'm missing. Everything is there, right?
You got to bake it.
Of course,
Yeah.
That's a process,
I know, but there's trick questions all over, so I just cover all my bases.
Okay, so this is how we go about making a cake. Then let's say this cake is, it gives us 5 slices per person. So 1 cake feeds 5 people. I know these are really big pieces of cake, right? But come on, can't give people small pieces of cake. You don't want any left over because cake isn't as good the next day as it is the first. Okay, so 1 cake feeds 5 people. Let's see. So Diego and Damaris is getting married. So, and they invite us to their wedding. But the deal for us going to their wedding, we have to bake a cake. We have to bake cakes for them. They're expecting about, say, 35 people at their wedding. They want to keep it small, COVID and everything. They don't want to be too crazy. So they're expecting 35 people at their wedding. How many cakes am I going to need?
7.
7, right? And how did you do that calculations, right? Because you
35 divided by 5, or
so our
Yeah.
given is 35 people, right?
Mm.
And we know that ratio was for 1 cake, 5 people. Now you're doing the shopping, right? You're shopping to bake all these cakes, and you need to get all the stuff that you need. Are you going to go in? I'm just going to get 4 eggs. Is that going to be enough for our cake?
No.
No, it's not going to be enough for our cake. We'd have to calculate how many eggs we're going to need. How many eggs are we going to need?
2 eggs.
So 2 eggs per cake, right?
Uh-huh.
Per 1 cake. So how many eggs is that?
14 eggs.
Okay. So how many of you guys do this on a daily? Like you cook for people and you're like, okay, so I have 8 people coming over. I make this really cool dish, but it usually feeds 4 people. So do you guys do that? Anybody do
Yeah.
that? Right? So you guys are doing it already. You've been doing chemistry your whole life without even knowing it. Have you realized that? You're doing those calculations on a daily. Right? I mean, I just put them in this nice little grid to help me see it, right? But you just told me, what was it? Whitney she whipped that out of her head like that. Oh, 35 people. Oh, that's just 7 cakes. That's all you need, right? And then was it Erica? Erica was like, oh, 7 cakes, 2 eggs, oh, 14. You're just whipping it out like that. So you guys have been doing chemistry your whole life because this is all it is. It's just this recipe, right? It's all about the cake. Okay. Are you with me?
Yeah.
Okay.
Yes.
So don't let the
Yes.
equation freak you out. You've been doing this. You own this. This is your wheelhouse. Okay. Now, the equation is just a recipe for us. It's just that beautiful recipe. So when you get it balanced, it's perfect. Just like you guys balanced this recipe here by looking at the back of the box, right? You sit there, 1 box, 1/2 a stick of butter, 2 eggs. I mean, you guys whipped that out like that, didn't you?
Mm-hmm.
Yeah, it's the
Yeah.
same concept, okay? So let's talk about a chemical equation now. Shift my screen. Okay, so here's our chemical equation. It's already balanced for you. We have 4 ammonia plus 5 oxygen gas is going to yield 4 nitrogen oxide and 6 water. So we know that we can set up ratios, just like we did with the cake. So we know that for every 5 moles of oxygen, there are going to be 4 moles of ammonia. For every 5 moles of oxygen, there are going to be 4 moles of nitrogen monoxide. For every 5 moles of oxygen, there are going to be 6 moles of water. And we know that because of the equation. And we know that that's quantity, right? We're not talking about mass, we're talking about quantity. So we can use moles, or we could even use particles if we choose to use particles. Now, I hate traveling around with big bowls of particles, right? We like to have nice little bundles. Oh, this is a mole. Right? It makes it easier for us to work with. Okay, do you guys understand that?
Can you do a problem?
Of course I can do a problem. That's our next deal.
Okay.
If 3.20 moles of ammonia reacts according to the equation, how many moles of water will be produced? Okay, so let's go back here. What was our given? What was our given?
Or 3.20 moles of
Okay,
ammonia.
so 3.20 moles. So we're always going to start off with what our given is after we have that balance equation. The very first thing that we always want to do is get a balanced chemical equation. And we know that's ammonia. Now remember, it's just like the cake. Okay, so in this situation, we're working with quantity. Moles is quantity, right? So if I want to get, the question is, the final part of the question says, how many moles of water is going to be produced? So our goal is to find moles of water. Okay, so if I'm talking about the number of moles of water, and I'm starting with moles of ammonia, first thing I want to do is get rid of the moles of ammonia, right? So what is the relationship of ammonia to water? Elizabeth, for every 4 ammonia, how many water can I make?
5.
5 of water?
6.
6, right? So it's 4 to 6. So in that case, I want to get rid of ammonia and I want to get to water. So four moles of ammonia to 6 moles of water. Okay, cancel out the units, and we're going to be left with moles of ammonia. I mean, moles of water. Okay, what is the answer?
So we just
Next.
multiply the 3.20 times 6, right?
And then divide it by 4.
By 4, yeah.
Yep.
4.8.
And then how many sig figs should I have?
3.
Okay,
So it's 4.80.
okay, piece of cake.
Can we do another one? Like,
Yeah, sure. We can actually use the same equation, right? Can I calculate how much oxygen I'm going to need to react with 3.2 moles of water? I mean, 3.2 moles of ammonia. So instead of looking for water, I want to find oxygen. So what would I do differently?
You add the 5. Well, you would have to multiply the 3.20 times 5, divide that by 4.
Okay, so I switch this out, right? I had to do it twice. How many sig figs should I have?
3. So it'd be 4.00.
Yep. Piece of cake?
Yeah.
So it's
Makes
very
sense.
much, yeah, it's very much the same thing that you're doing when you're thinking about, okay, I need to bake 6 cakes for that wedding or 7 cakes for that wedding. Same concept. You're using that chemical formula. Instead, you're saying, we call it a recipe in real life. In chemistry, we call it a chemical formula. This is just our recipe. This lets us know what we're going to get, how much we're going to get, you know, kind of like how many cakes you're going to get out of that, right? You guys get it?
Yeah, kind of.
Okay,
Yeah.
Good. Kind of is better than no. I don't know what the hell you're talking about, Dr. We're making progress. Progress is good. Okay, so let's move on. Maybe. If I there we go. Okay, so this process is called stoichiometry. Like I'm stoked to be doing it. Stoichiometry. Okay, so just the fact that we can use those moles to moles ratio from a balanced chemical equations to sit there and calculate how much product we have or how much of a reactant we're going to need to make a certain amount of product, right? It gives us that flexibility. We can go back and forth, you know, and do those calculations, okay? And we can do it at the particulate level, and we can do it at the molar level too, right? So that's the beauty of it. It gives us that flexibility. So that's why we want to make sure our chemical equation is balanced correctly. Because without a correct balanced chemical equation, it won't work, right? So like for instance, if we were sitting there making a box cake and I added 8 eggs instead of the 2, what would happen? Would that be a good cake?
No.
No.
Or if the recipe required a pinch of salt and I put in 5 cups of salt, how would that cake taste?
Salty.
Too salty.
Salty, right? So we want to make sure that we have a balanced equation and that we're not just throwing stuff in there just to throw stuff in. Okay?
Mhm.
So this specific chart relates to finding out the moles that we need.
Yeah, so it's to find out the moles that we need or the moles that we're going to be making,
Mm-hmm.
you know, so it could be either way. Yeah, that's a good question. How many moles of oxygen are required to burn 2.40 moles of ethane, C2H6? Okay, what am I going to do? First thing,
2.40 moles.
is that going to be my first thing?
No.
Why not? What else? What am I missing?
Do you need the molar mass?
Do I need the molar mass?
You need that full chemical formula, don't you?
That's right. We need our chemical equation.
Oh.
We can't do anything without the chemical equation, right? It's kind of like, okay, so we're going to bake a cake, but I've never baked a cake before and I don't have a recipe, right? So what am I going to do, right? I'm not going to do anything. You're going to sit there like, go bake a cake. I've never baked a cake before, right? So we need our recipe first. So let's get our recipe out. Okay, so it says, how many moles of oxygen are required to burn 2.40 moles of ethane? So what are my reactants?
Ethane and oxygen.
Ethane and oxygen. Okay, so we know the chemical formula for ethane. What is the chemical formula for oxygen?
O2.
Okay. So the person that did this on one of the exams, I asked a similar question and somebody gave me H2O, right? Look how far you guys have come, you know? Usually I have to say, come on, everybody, their first instinct is just saying, oh, it's O, right? But now you guys are remembering that it's diatomic. You guys are making me so proud. Okay, what are the products? Every time you
CO2
get,
and hydrogen gas.
there we go. CO2 and hydrogen gas. Is it hydrogen gas? Combustion reaction always going to give you the same things. Was it hydrogen gas?
I don't know. Yeah, it was.
Are you sure? Do you want to put money on it? How much money do you want to put on it?
Well, it says that the ethane is a gas.
It says that the ethane is a gas, yeah. But is it going to be hydrogen gas that we're going to get?
Just hydrogen?
Is it going to be just hydrogen? Which is
Man, I don't
hydrogen
know.
gas. Okay, well, let's make a bet, a little wager. Go back and look at your notes. So if you guys lose, and if I lose, I bake a strawberry cake for you guys. If you guys lose, you bake a strawberry cake for me. Fair? Combustion reactions.
H2O.
We just talked about it. What was that? I heard somebody say it was staticky. Somebody repeat that, please. The staticky person, please. Robot. H2O. Yes, that's correct. And it's going to be a gas. Okay, I expect my cake. I love betting. Can you tell I'm a gambler?
Wait, we the one that said it.
No, but you guys were saying it was hydrogen at first.
It's because you couldn't hear her.
Oh, okay. So are you telling me that I'm not baking you guys cake because I didn't lose?
Dr. Henry, I think we've been waiting for our lab kits. We should just get a cake for that.
I should give you guys cake for the lab kit.
Yeah.
Okay. What you guys are all gonna get a box cake in the mail.
Why not? We've been waiting for our lab kits.
I know. I'm still waiting for stuff to come in. I just got a message from one of the companies too. And here's the funny thing. If you're planning to order for next semester, you need to order now. I haven't still got the same stuff that I ordered this semester here, and you're telling me I need to order now?
I'll be waiting next semester then. You have our addresses.
Yeah, I do. Okay, so is this balanced?
No.
Okay, let's balance it. Okay, what is my next step to balance it?
The CHO, and we figure out how many they have.
Okay, so how many carbon on the product side? I mean, on the reactant side.
2.
Product side,
2.
there's 2.
Wait.
1.
1. Okay.
Oh.
Hydrogen,
6.
and on the product side,
2.
oxygen,
2.
And-
And the other one 3.
okay. Good. Is it balanced?
No.
Okay, so let's balance it. How can I get? I have 2 on my reactant side. How can I get 2 on my product side?
2 on the product side in front of the C.
Okay. What about, and then let's see.
Times 2 is 4, 5 oxygen.
Okay. Now what about my hydrogens? I have 6 and I have 2 on my product side.
So 3.
Oops. Okay, that gives me how many oxygens?
So that'll be 3 plus 4, 4, 5, 6, 7, 7.
Okay. So that's an odd number. Damn it. So what am I going to do?
The 7, divide that by 2.
That's right. So then I know I'm going to do what next?
Multiply the whole equation by 2.
Okay. And I get, let's see.
2C2H6
2C2H6
plus 7O2 gas
plus
4CO2 gas
plus
6H2O
Okay. Piece of cake, and we know that's a gas too. Okay, so now that we got a balanced equation, we can start working our problem, right? Our given. So this is our given. And what are we looking for? What are we looking for?
Moles of oxygen.
So we want moles of O2. Okay, so what am I going to do? Other than stand here and look pretty. iPhone, who's iPhone? iPhone, who are you?
That's me, Dr. Henry.
Okay.
Giselle.
Damn it. See, she knows. If I hear her voice enough, I'll try to pick it out. Hey, Giselle, you're going to help me out, right?
Yeah.
Okay. So what am I going to do, Giselle?
Well, I'm thinking you're gonna have to you're gonna multiply by the, is it C2H6?
Okay. Am I going to multiply?
I'm sorry, divide.
Divide. Okay. So, and how many moles of C2H6 do I have? According to my equation.
You have 2.
Okay.
On that part, Dr. Henry, do we use the reactant side always?
It depends on what you're looking for, right? And what you're given. Sometimes, since we're trying to get rid of C2H6, so then we're going to start off, we're going to put that at the bottom to get rid of that, right? Because you know, if you have something divided by that same thing, it cancels those units out, right?
Okay.
Yeah. And then we're going to multiply by what? What do we want?
Are you gonna do 1 mole?
Is it going to be
Or
one mole?
mole O2. Or 7, sorry.
Okay. Yeah, because you've done all this hard work of using that equation, of getting that equation, you've got to use it, right? And think about it. When you're thinking about your recipe, right? You don't say, okay, it's just 1 egg, right? No, you say how many eggs you're going to need for that recipe, right? Okay, so then these units are going to cancel out, and then we're just going to be left with that. And you guys are going to get what? What is our answer?
8.4. Well, 8.40 because we have 3 significant figures.
That is correct. Piece of cake? Strawberry? With chocolate frosting cake?
That we're expecting at the door next semester. Yes.
You guys are giving me grief here. Okay. Let's see. Okay, everything going good so far. We're getting a taste, we're getting a feel for it.
Yeah.
Good.
Yeah.
Okay, so let's move forward. Okay, so gotta clear this out. Okay, now when we're doing stoichiometry, a lot of times we're given mass, right? And so if we're given mass, mass is okay and all, but it's hard for us to sit there and do things with just mass. So we want to convert it to moles, right? So if I'm given mass, I want to convert to moles, right? Because we know that our equation is based upon moles, and moles is our gateway drug, okay? Because moles allow us to go to mass, and we can go to particles if we want to. So moles is our gateway drug. So we always want to go, if we're given mass, we want to convert to moles. Now, everybody unmute yourself. Unmute yourself right now. Everyone, come on, unmute yourself. Unmute yourself. Come on, come on. Eileen, come on, everybody, come on. Diego, unmute yourself. I'm not asking you to show me your camera. I know you're in your underwear. Whitney.
Yes.
Okay, now repeat after me.
Yes.
If given mass, I convert
given
to
mass.
moles.
If given
Given
mass,
mass, I convert to moles.
Moles.
Okay, if given mass, I convert to moles.
If
If
given
given
mass,
mass,
I
I
convert
I
to
convert
moles.
to moles.
If given mass, I convert to moles.
If
If
given
given
mass,
mass,
I
I convert to moles.
Okay, you guys got that, right? Amen.
yes.
Okay, now, if you're given mass, what are you going to do?
Convert to moles.
Convert
Okay.
to moles.
Okay, so if we're given mass, we can use the molar mass to convert to moles. Okay, so we have to use that molar mass to do that conversion so that we can use our chemical equation to do stoichiometry. But we first have to get it to moles, right after we get that chemical equation balanced. Balance the equation, then we're going to convert that mass into moles. Okay, you guys ready? You want to test this out? You want to see those skills?
Yes.
How many milligrams of nickel 2 chloride are in a solution if 503 milligrams of silver chloride is precipitated in the reaction of silver nitrate and nickel 2 chloride solutions? Step 1, what are we going to do?
Write out the chemical formulas.
Write out the chemical formulas. Okay, so what are our reactants?
Nickel 2 chloride.
Nickel 2 chloride.
And
Is that a reactant or is that a product?
oh, okay.
Oh, no,
So silver
no.
chloride.
No, you're right.
No, nitrate.
You're
Never
right.
mind.
My bad.
I don't
I was just giving you a hard
It's a
time. Nickel
reactant.
2 chloride
Oh, God.
is a reactant. I'm just testing this.
Okay.
Don't question yourself. Be confident. Come on. Okay, so nickel 2 chloride. What does nickel 2 chloride look like?
Is it just NiCl? Cl2?
There we go.
Yeah. Okay.
Gas, liquid, aqueous, or solid?
Is it aqueous because it's in a solution?
That is correct. Okay, what is our other reactant?
Silver chloride. Oh no, it's precipitated. So silver nitrate.
Okay. And what does silver nitrate look like?
I had to find the table. Okay, so it's silver, which is Ag. And then that has a charge of 1 unless it's otherwise noted. So then it would be in parentheses NO3, I believe. Nitrate, yeah.
So do I need the parentheses?
Not really, but I don't know, in case you have to change how much there is or anything. I don't know.
But you told me it was 1, right? And NO3 is, what's the charge on NO3?
-1.
Oh, so it balanced out perfectly, right? So solid, liquid, gas, or aqueous?
Aqueous?
And then we're making
Silver chloride?
okay. Silver chloride looks like what? Chemical formula?
AgCl.
Solid, liquid, gas, or aqueous?
Aqueous. Solid.
There we go, solid. Yep, anytime you see that term precipitate, oh, solid, right? Okay, and what would be the other product?
Nickel nitrate.
Okay. Chemical formula for nickel nitrate?
Ni, and then in parentheses, NO3, 2.
Okay,
Of those.
good job. And you said aqueous, right? Now
Yes.
you're going to assume that it's aqueous because it doesn't tell you otherwise.
Okay. All right.
That was the question, right? That was your next question.
Yeah.
That was
And then
good.
shouldn't there be a little 2 after the nitrate?
You are correct. Good job.
Okay.
Okay. Is it balanced?
No.
No. Okay, so how do I balance it?
Write out all your products and reactants.
What type of reaction is this, by the way?
Double replacement.
A double replacement reaction. So if our polyatomic ion moves together all the time, then we don't have to separate it. So we can write it as NO3 when we're doing our balancing act.
Okay.
Okay, how many AGs do I have on the product side?
Silver? Is that what you said?
I mean, sorry, yeah, silver, I said AG. Yes.
Yeah, 1, sorry.
1.
It came through weird.
No, it's my bad because I was being lazy and not calling its name. How many nitrates do I have on the product side and the reactant side?
Products you have
1.
2, reactants you have 1.
Okay. How many nickels do I have on the product side and the reactant side?
1 on each.
And then how many chlorines do I have on the product side and then the reactant side?
2
1 on the
reactants,
product.
or
Yeah, 1 on product and 2 on reactant.
Okay. Okay, is it balanced?
No.
What do I need to do to balance it?
Multiply.
By what and where? Where am I going to put it?
Multiply the nickel, or not the nickel, the silver nitrate by 2 on the left.
Okay, so then that gives me 2 here, and that gives me 2 here. Okay, so my nitrates are balanced.
Yeah.
Okay,
And then multiply the silver chloride on the product side by 2.
okay. So then that gives me my, now are we good? Everything balanced?
Yes.
Piece of cake?
Yeah.
Good.
Yes.
Okay, so now that we have everything balanced, what is our given? What are we going to start with?
503 milligrams.
503 milligrams of what?
Silver chloride.
Okay, so silver chloride, 503 milligrams. So I'm going to share something with you because I know you guys are at that level that you guys can get it. You know, not all my classes are there, right? But I think you guys can get this, right? So if I'm talking about molar mass, and I have milligrams over millimoles, that's going to equal the same value if I had grams over moles, which is going to equal the same value, which is kilograms over kilomoles. Which is going to equal the same value if I had picograms over picomoles. So long as that unit up top is that same, if that prefix up top is the same prefix at the bottom, then it's going to be the equivalent as if it was just the normal. Do you guys understand what I'm saying?
Yeah.
Okay. Okay, that's just my hint. Now, we have mass, right? What is that rule? If we have mass, we got to do what first?
Convert it to moles.
We have to convert to moles. So how can we convert to moles? What am I going to use?
The molar mass.
The molar mass. What is the molar mass of silver chloride?
Two.
Molar mass of silver chloride is 2. Not number of moles, the molar mass. Where do I find the molar mass at?
You add together the atomic mass of like
The
what's in
atomic
the
mass. That's
thing?
right.
Yes.
Okay. So the atomic mass of silver is?
I don't have my table with me. Let's see. $107.8 or 0.9.
Let's go 107.9. Okay. And we have how many of them?
Just one.
Okay. And then let me move this so it's not so close to our equation. And then what about the chloride?
35.4.
And how many of them do we have?
Just one.
Isn't it 4, 5?
Yeah, it is 4.5.
Okay.
Sorry.
No, but I understand why you would round it. Yeah.
Mhm.
Okay, so and there's just one, right? Okay.
Mhm.
So let's add this together. Let's see. Yeah. We could just we could have done what you did. Okay, so that's 3 point. Yeah, if I can add 12 plus, 12 plus 5. 5 plus 7.
12.
Okay, good. I'm struggling today. I only had half a cup of coffee. Okay, so and we know those units are either grams per mole or they could be milligrams per
Well,
millimole.
it would, real quick, sorry, it would be 143.3 because the 9 and the 4,
See?
13, right?
Yep.
It would be 7 plus 6.
See, guys, you got to keep me on my toes. You can't just assume everything I say is right, right? Okay. Milligrams per millimole, right?
Mm-hmm.
Okay. So what's going to go on top and what's going to go on the bottom?
On the bottom, it'll be 143.3 milligrams, and then on top, it will be 1 millimole.
Oops. GCL. Okay, so then that gets rid of mass and we've converted to moles.
Mhm.
So what is our next step?
Then 1 millimole equals 1,000, or no, 1,000 millimoles equals 1 mole.
Do I need to go into moles? I mean, can I just keep using millimoles? Because isn't my ultimate goal to get to milligrams?
Yeah.
Oh, yeah.
Okay. So let's say. So how I have silver And what is it that I want?
Nickel chloride.
I want nickel 2 chloride. So how can I get from silver to nickel 2 chloride? I have moles of silver chloride. How can I go from moles of silver chloride to moles of nickel 2 chloride?
Go through the reaction.
Through the reaction. So what is the mole-to-mole ratio?
1-to-1.
Is it 1 to 1?
Is
I have
it?
nickel here. I see 1 in front of nickel, but I see
Yeah,
2 in front of silver. So what am I going to do?
1-to-2.
It's a 1 to 2 ratio, right? So I'm putting 1 on top. 1 millimole of nickel 2 chloride over 2 moles, 2 millimoles of silver chloride. So, oops, let me spell that right. Okay, so then my millimoles cancel out, and then now I'm left with millimoles of nickel 2 chloride. So if I want to go from moles to mass, what do I need to do?
Use the molar mass again.
I'm going to use the molar mass. And so how do I calculate the molar mass of nickel 2 chloride?
The atomic mass.
Okay, what is the atomic mass of nickel? Oops,
Are you good on time? It's 9:40.
I'm not actually. I'm running late, but I want to finish this problem. I'm
Okay.
obsessed.
Do you want me to just give you the whole number of that?
Yep.
Okay, it's just 129.5 or
Okay.
0.6, round up.
Okay, so 126 milligrams per millimoles.
129.6.
Oh,
Sorry.
129.6.
Yeah.
And we know there's 2 chlorine at 35.45. We add it together. And so we get. Okay, so what's going on top? What's going on bottom?
You would put 129.6 milligram or milligrams, yeah.
Okay.
And then that would be 1 millimole of nickel chloride.
Okay. Okay, so we multiply it all the way across, and how many milligrams are we going to get?
Let's see, 503 divided by. Mm, 503 divided by 286. It would be 1.75.
Okay. Are you sure? That seems a little small. So 5.
Is it?
I got 907.5, but I rounded up, so I got 908.
Oh yeah, I forgot though. 129.6.
You said
'Cause we
900
have
and
3 stick fix.
okay,
Mhm.
repeat that number.
It's 908.
I think that's a little incorrect too. Because I get 228 milligrams.
Okay, then probably did something wrong in the calculator.
Okay, so 503 times 129.6 divided by 143.3 and divided by 2. Let's see. Yeah, sorry. 27, sorry, 127, you're correct. Okay, piece of cake.